working on this every day up until the test on Friday. So you are going to just, as we go through it, you might just have to, you'll turn it in what we did. And you don't have to break it apart. You can just keep turning it in each day, okay? Please check over. Many of you are missing some assignments. Get those things to me as soon as possible. Grades for me, all late work is due by Friday. Okay. Let's take a look at number 8. It says define P such that the following functions are continuous at x equals 3. For a function to be continuous, the left and right limits have to match, and the function has to be defined at that same point, okay? So when we look at this, the first thing we should note is that something funky is happening at 3. This function here is undefined at 3. But if you plug in 3 to either f or g, you will find you get 0 over 0, which we found was a hole in the graph. So all we're going to do is try to plug the hole. That's it. So what you're going to do is we are going to try to factor this function. So if you'll notice, that is x squared plus 9 and x squared minus 9 over x squared minus 9. So all I've done is tried to get rid of that x squared minus 9 factor. Well, this is the difference of squares. So you'll notice I've just taken the square root of each. One's a plus, one's a minus. And then we can cross that out. So technically, this function really looks like 3 times the quantity of x squared plus 9, except it's got a hole. So we need the hole to be plugged at 3. So if you stick 3 into this, you get 9 plus 9 is 18, and 3 times 18 is 54. So what we want is we want this to plug the hole at 54. Okay, so how do we do that? Well, we know that px plus 9, we want that to equal 54 when x equals 3. We don't care about any other point. We only care about what's happening at 3. So if we put a 3 right there, we get p times 3 plus 9 has to equal 54. So we want the hole to be plugged so that it reaches a height of 54 and fills that in for us. Well, if we subtract 9 from both sides, we get 3p equals 45, so p equals 15. So for that line to fill it perfectly, to get a value of 54 at x equals 3, the p has to be 15. Now the easier version is this version. Okay. Both of those things are factorable. We do get 0 over 0. Let's factor both top and bottom. The formulas for factorization are up on the board if you forget those. That's x minus 3, x squared plus 3x plus 9. That's the hard one. That's that cube formula. And this is x plus 2 and x minus 2. Oh my gosh, how about 3? X plus 3, x minus 3. Okay. Because what's happening here is the x minus 3's are going to cancel. That's what's causing that 0 over 0 effect. So we get x squared plus 3x plus 9 over x plus 3. So we want p to fill the hole, but we have to know what value we're using. So if you stick 3 in to that whole thing, you get 9 plus 9 plus 9 over 6. 9 plus 9 plus 9 is 27 over 6. And p has to equal 27 over 6, which is 9 halves. So that one's a little easier because we don't have an equation for p. P is just the p we want. It's just that 9 over 2 or 27 over 6. So there is some things about continuity on the test. Okay?
Can you stay on that?
Yep. Everybody good with that one? Okay. Next thing we're going to ask is just some derivative stuff. So we do have to remember all our rules of derivatives, the product rule, the quotient rule, all those rules. So let's just start with 21, and we're just going to do a few in this little section. So let's look at 21. We have learned that when we're doing a derivative, sometimes a rewrite is helpful. Same thing for antiderivatives. So let's just take a moment and rewrite that as x over x cubed plus 1 to the 1/3 power. Now please note that they want the derivative at 1. So I would not simplify it. I'm just going to do that first step derivative, and then I'm going to put 1 in and see what the heck happens. Okay. Now remember, this is a chain rule with a quotient inside. Okay. So we have to do the chain quotient rule. Okay. So the derivative, we're going to drop the 1/3 in front. The stuff is going to stay there. The stuff stays there. The power goes down by 1. We're going to do the derivative of the stuff, which happens to be a quotient. So it is the bottom in parentheses times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Okay, let me go over that again. Bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Now we want to know what is happening at 1. Okay, so first let's talk about what's happening for the fraction. If we stick 1 into that fraction, we get 1 over 2, or 1/2. We can't do a whole lot with that. I'll show you the limited amount of things that we could do. If we stick 1 in here, it was 1 we're sticking in, right? Mm-hmm. Okay. If we stick 1 in there, we get 2 times 1, or 2 on the top. We get minus 3, all over 2 squared, or 4. Now the negative on this exponent can flip that over, and then now it's positive. I don't know what else you can really do. You can't, the 2/3 power on a 2 is, I don't know, it's a number. And then that's just negative 1/4. So I think there's not much you can do. You could probably make that negative 2 to the 2/3 over 12. You could also possibly square that and make that the cubed root of 4 over 12. But again, there's not much we can do to that 2 to the 2/3 power. So you're kind of done. I don't know. It is what it is. There you go. Okay. Okay. Let's keep going. Yeah, we're going to do, well, we'll see. I think I might skip. Well, we'll see. We'll just keep going. So let's go ahead and now do 23. It's a similar idea, but it says we want the second derivative at x equals 1. We want the second derivative at x equals 1. So let's make this prettier by making it 3x to the 4/3 minus 1/3 x to the negative 3. So you'll notice that 1/3 that was attached to the x cubed, that 1/3 is going to just kind of act as a constant. Just pull it out in the front. Okay. Okay. So let's do our first derivative. So our first derivative, the 4/3 drops down in front, multiplies by the 3, we get 4. Power goes down by 1. Negative 3 drops down in front, multiplies by the negative 1/3, makes that a positive 1. Power goes down by 1. Everybody see how we got our first derivative? Okay, now our second derivative. Do it again. We get 4/3 x to the negative 2/3 minus 4x to the negative 5. And then finally, they want to know what happens when x is 1. So you're just going to stick 1 in. Now what's great about the number 1 is 1 to any power is still 1. So this is just 4/3 minus 4. So it's just a simple calculation from there. As far as the test is going to be multiple choice, so the test will give exact answers. So make sure that you have your calculator on like fraction mode, or you just do with that. Yes.
All of us multiple choice?
Yeah, the whole thing's multiple choice. So if we make this thirds, that's 4/3 minus 12/3, or negative 8/3. Everybody good with that one? Okay, let's jump now to 26.
Where?
26, we're going to go to 26. It says, if the sine, f of x is the sine of 3x cosine of 2x, find f prime of pi over 6. Okay, so let's talk about how we do that one. To do that one, put a dot between them. That is a product rule, but it does have a chain in it. This is the sine of 3x, the cosine of 2x. There is a constant stuck inside, okay? Okay. So if we do the first derivative, we're going to write down the first times the derivative of the second. What is the derivative of a cosine? Negative sine. So it's going to be the negative sine of the stuff times the derivative of the stuff. Don't forget that part. Plus the second times the derivative of the first. What's the derivative of a sine?
Cosine.
A cosine of the stuff times the derivative of the stuff. So initially, that is what we're going to get for our first derivative. But they want to know what's happening at pi over 6. 3 times pi over 6, just stick the 3 on top by the pi. It's 3 pi over 6, which is pi over 2. Two pi over 6s is really pi over 3. Two times pi over 6 is pi over 3. 3 times pi over 6 is pi over 2. Okay, so we kind of get that. Sine of pi over 2 and cosine of pi over 2. Pi over 2 is 90. So this right here is 0, and this right there is 1. So this portion, when we plug it in now, at this point, that's going to be gone because it's going to be 0. So this one is not. So that's the one, focus on that one. So that's going to be 1 times negative the sine of 60, which is square root of 3 over 2, times 2 plus 0. The 2's in the top and the 2 in the denominator cancel. We just get negative radical 3 as our answer.
So are we gonna have a lot of this stuff?
I'm sorry?
Are we gonna have a lot of like this stuff where we use a unit circle or whatever?
No, a few.
Do you think I should draw a unit circle with that card?
I'd draw the first quadrant. I wouldn't waste my note card on a unit circle. No.
Okay.
First quadrant should get you most, because then you could always extrapolate from there. Okay. So now I want to find one about the max and min on an interval. So let's find where that would be. I'm looking, people. I'm sorry. Increasing, decreasing, concave up, inflection points, maximum on the end. Okay, everybody, could we jump now to 36? It says to find the maximum and minimum values of the function on the interval and repeat the problem for the interval -3, 0. Okay. Now, our first interval is 0, 3. So remember our steps, and this is where our vocab comes into play. If you jump to the vocab,
Which number is this one?
36, and if you jump to the vocab, we had done a maximum on an interval already, I believe.
It's 21.
Thank you. So if we look at number 21, let's go over the rules. Okay? So let's follow these 4 rules. We are going to take the derivative, find any critical numbers in the interval, plug in the ends and the critical numbers. The max is your largest, the min is your smallest. Okay? So that's where that is really going to help you as far as a study guide and anything you want to write on your card. So if we want to do this, the first step was to take the derivative. The second step was to find any critical numbers that are in the intervals. Remember, critical numbers are where the first derivative equals 0 or is undefined. This is a polynomial. It is always defined, but it can equal 0 if we add 12 to both sides and divide by 3. We find critical numbers of plus or minus 2. Don't forget the plus or minus. Now, for our first interval, 0 to 3, which one of those critical numbers are in the interval? Are they both in the interval, one in the interval? What's in the interval from 0 to 3?
Plus 2.
Just 2. So we are going to plug into the original function 2, the endpoints of 0 and 3. So remember, you plug in the endpoints and you plug in the critical number only that's in that interval. If you plug in 2, you get 8 minus 24, which is -16. If you plug in 0, you get 0. If you plug in 3, you get 27 minus 36, or -9. This is your minimum. This is your maximum on that interval. Now, they did say to repeat the process for the interval of -3, 0. We're always plugging it back into the original because that's where we want to know where the biggest and smallest is for that function on the original. Okay. This time, what critical number do we use? What critical number do we use for the interval -3, 0? -2, right? You still have to plug in the endpoints of that interval. So this time we don't use +2, we only use -2. If you plug in -2, you get -8 plus 24, or 16. If you plug in -3, you get -27 plus 36, or 9. If you plug in 0, you still get 0. This time, this is our max, and this is our min. Okay? So you will have to know how to find the max and min on an interval. Any questions on that? Okay, now we're going to flip back up to some of the problems from the start. So if you could scroll up. Scroll up, please. We're going to go all the way up to problem number 4. We're going to go all the way to number 4. We're going to add a little piece to that. We're going to find f of g of 2 as well. Now, I'm only going to do part, we're going to just do part A. Okay. It says for the functions f and g, find f of g, g of f, and the domains of each. Okay. So let's start with f of g. F of g is really f of g of x. So we have to plug g of x inside of our f function. What numbers can you not plug into a square root?
Negatives.
We can't plug negatives, right? So we know at this point our domain has to be everything that's greater than or equal to 0. We only can plug in positive stuff. Okay. Now we plug that positive stuff in, and we're plugging it into this. So now let's stick that in there. F of the square root of x is 1 over the square root of x squared minus 1. Well, the square root of x squared is just the square root of x. That's 1 over x minus 1. What number messes up that fraction? 1. So we know that x is not allowed to equal 1, but x can be anything greater than or equal to 0, but 1. 1 is the only thing that messes that up. So that's our domain. Now let's put that in more calculus sort of notation. So if we think about the number line, let's think about 0. And then our numbers that have appeared are 0 and 1. I can do anything from here to here, but I gotta skip 1 because it messed up my fraction. So my domain for this is anything from 0 to 1. I'm gonna skip over 1, but then I can keep going. So you first contemplate, what function do I start with? What causes issues with it? Then, if I stick it in, is there anything that doesn't work in my result? Do you see how that works? Okay, so let's now do g of f. G of f, we're sticking the f function in. So this is g of that fraction, 1 over x squared minus 1. What screws up the fraction 1 over x squared minus 1? 1 over x squared minus 1. What screws that fraction up? Can anybody tell me what screws that fraction up? 1 screws it up. There's actually one other value. -1. So we know that x is not allowed to equal plus or minus 1. That's going to mess that fraction up. Okay. Now let's stick it into, it has to go into where? It has to go into a square root. So this is just the square root of that fraction. So we have to say, okay, square roots have to be greater than or equal to 0. So 1 over x squared minus 1 has to be greater than or equal to 0. 1 is already positive, so we just have to make sure that x squared minus 1 is positive, which is x plus 1 times x minus 1. If we make a dreaded plus minus chart, we know that 1 and -1 messed it up. Let's think about what's positive and what's negative. Well, if you stick in those test values, let's do 0, -2, and +2 into here. If you plug in -2, you get -1 times -3, which is a positive. If you stick in 0, you get 1 times -1, which is a negative. If you stick in 2, you get 1 times 1, which is a 3 times 1, which is a positive. So we want the greater than or equal to sections. So the domain for this one's very hard. We had to skip 1 and -1 because that messed up the original. When we stuck it in, we had to get positive junk. So we have from -infinity up to -1, and then from 1 to infinity. I am not going to give you one where the domain is that difficult, but you know, better off to see it now. Okay, now let's talk about f of g of 2. F of g of 2. We're going to stick 2 into the g function, Now our g function is the square root of the number, so that's just f of the square root of 2. And then we're going to put that into our f function. So that's going to be 1 over the square root of 2 squared minus 1. The square root of 2 squared is 2. 2 minus 1 is 1. That's 1 over 1, or 1. Yeah, I know, it's a lot, but... Okay. So that is that one. Now, we are looking for limits. Let's go to number 6, please. We're now going to do number 6. It says for number 6a, find the limit as x approaches 1. See how 1 is our ends? So we have to see where is it approaching here, where is it approaching here, does it match up? Well, we don't really care about that. Because remember, a limit is what's happening from the endpoints. So we're going to focus on these two pieces. If you stick 1 into the top, although it's an open circle, we are heading to a value of 4 times 1 minus 2, or 2. Even though it's an open circle, on the bottom, we are heading to a height of 2 minus 1, or 1. Do they match? Do they match? No, one is coming to a height of 2, the other's coming to a height of 1. The limit does not exist. The limit does not exist. Now let's do the same exact thinking for 6b. We're finding the limit as x approaches negative 2. Note that negative 2 is our border. So we have to come in from the left and from the right and see if they match in order for the limit to match. If I plug negative 2 into the top function, I am going to get negative 2 plus 5. It is going to a height of 3. If I plug negative 2 into the bottom, I get 8 plus 2 minus 7, which is 10 minus 7, or 3. They match. The answer is 3. So if they match, that's your answer. If there's a value in the middle, that only affects continuity. It does not affect the limit. So that is your answer for number 6a and b. Okay, now let's go and talk about the intermediate value theorem. I just got to see where there's a problem like that. Anybody notice one that says intermediate value theorem? I thought there was one somewhere. Oh, here we go. Number 52. Everybody jump to 52. It says, in each of the following, determine whether the intermediate value theorem guarantees the equation has a solution in the specified interval. What the intermediate value theorem says, if you have a function that's continuous, so you could draw it without ever lifting your pencil. If it is positive, and then if it is negative, there has to be a 0 between that because you didn't lift your pencil, okay? So what does that mean? Well, okay, so first off, it's got to equal 0. So see how A is equal to 0, but B, C, and D are not. So that's a problem. Initially, you always have to get it equal to 0. Now let's start with A because it's already equal to 0. And all we're asking, is it continuous there? Oh, sure, it's a polynomial. It's always continuous. I never have to lift my pencil. Plug in 1. If I plug in 1, I get 1 plus 2 minus 10 plus 5. What is that? That is 8 minus 10, or negative 2. And then plug in 2, I get 32 plus 8 minus 20 plus 5. What is that? That's 12, 20, 25. And then just ask yourself, is 0 between those two numbers? Yeah, so then this is a yes. the intermediate value theorem guarantees a solution on that interval because one was positive and one was negative. That is far as you got to go. Okay? So it's got to equal 0. So let's, since we can kind of see it real well, let's take a look.
Those are for Friday. I forgot that I have them. Tests.
Okay, now let's take a look at C. We have to get it equal to 0. So let's just subtract either one. It doesn't matter which side. Go for it. I don't care. It doesn't matter. Okay? Okay. If we plug in 0, we get, okay, now you're only plugging it into this, and we're just looking for a positive and a negative. Okay, if I plug in 0, I get 0 minus the cosine of 0, which is 0 minus 1. That's a negative. Okay, so I found a negative. Let's see if the other side provides me with a positive. That's pi minus the cosine of pi, which is pi minus a negative 1 is plus 1. That's a positive. So that's a negative. That's a positive. So that's a yes. It's only if you get a positive positive or a negative negative that you have an issue. Okay? Another thing. Between 0 and pi, is cosine defined everywhere? Yes. Now, if it was tangent, it might not be. If it's secant, it might not be. But cosine is defined everywhere on that interval. Okay? Let's look at B. Got to get it equal to 0. We're just going to plug in 4, plug in 9. The square root is defined for the positives. 4 and 9 are positives. It's defined. We're good to go for that part of things. Okay. If we plug in 4, we get 4 minus the square root of 5 minus 5. That's a negative, I believe. Yeah, that's a negative. Let's plug in. What did I just plug in? I did not plug that in right, did I? The square root of 4. The last I checked, because that's an x. I'm sorry. The square root of 4 is 2. Anyway, that's a negative. Okay, now let's plug in 9. We get 9 minus 3 minus 5, which is a positive. So yes. Now D. Tangent is undefined at pi over 2. Isn't pi over 2 right smack in the middle of those two things? So this is a no. It is not guaranteed to have something if it is undefined. So that's a no. Okay. Oh yeah, I'm sorry. Oh, I'm sorry. So if your interval has a point somewhere that is undefined, the intermediate value theorem says that it only works if it is continuous along that entire function. So pi over 2, the tangent of pi over 2, you get 1 over 0, which is undefined. So that is undefined, and so we cannot even say that the intermediate value theorem will work for this one. So but basically for the intermediate value theorem, if it's a continuous function, plug in a positive, or plug in and get a positive, plug in and get a negative, you're guaranteed a 0. But it does have to equal 0 or it doesn't work. Okay? Okay, we're going to, we just have a few more things to do. We're going to talk about limits. We'll do that as much as we can until the bell rings. Could you please look, see this number 7? Let me just kind of pick and choose from there. Let's do 7E. Remember, when you plug in, if you get 0 over 0, that's a hole that you can fix. But if you get a number over 0, that's a vertical asymptote. You can't fix that. So if you look at E, and you plug in 7, you always try the value first. If you plug in 7, you get 98 over 0. you have just found a vertical asymptote. So if the notation says we're coming in from the right, we're going to plug in 7.1. Okay? If we're coming from the right. So let's plug in 7.1. 7.1, you get a little more than 98 on the top, but it's still a positive on the top. If we plug in 7.1 on the bottom, we get a positive on the bottom. Positive over positive means that we are going to positive infinity on the right. So that's your answer for E. Now let's look at D. If you plug in 7, you get 98 over 0. So here we would plug in 6.9. We would get a positive over a negative. It's going to negative infinity. So our answer to 7D is negative infinity. Our answer to 7E is positive infinity. Now let's look at our answer to F. If those both match, the answer to F is whatever that you got. If they're different, what's happening is at 7, one side's going down, one side's going up. So we can't pick an answer. So when that happens for this one, we just say it's undefined. There's no answer. So watch that. Be careful with that. Okay, watch that and be careful with that. So if you plug in and get a number over 0, you have found a vertical asymptote. Deal with it how you have to deal with it. Now, if we get 0 over 0, let's look at the B right above this. Let's look at this one. You always try direct substitution. If we plug in -1, we get 0 over 0. You can fix that. And for a polynomial, you'll most likely fix it by factoring. That's x plus 1, x squared minus x plus 1, using the board formula. And this is x plus 1 and x minus 5. You fix it by crossing out the factor that is causing the issue. So if I stick in -1 on the top, I get 1 plus 1 plus 1. If I stick -1 in the bottom, I get -6. The answer is -1/2. So you got to be mindful for these limits. Plug it in first off and foremost. You always try direct substitution. You see what happens. If it works, there you go. If you get 0 over 0, it's telling you one thing. There's a hole in the graph. You can fix it. If you get a number over 0, there's a vertical asymptote. You can't fix it, but you only have an answer if both sides of the graph are going to either positive infinity or negative infinity. So is this bringing back some, are you remembering some of this stuff? There's a lot of stuff between now and Friday. You should be looking at calculus every single night, or this test is going to go bad. You got to look at calculus every single night between now and Friday morning. Okay? I have lots of review videos I will post for you, and I will send you playlists, old videos that I've had. As I do these each day, I'll record them and save those for you. But between now and then, you have the detailed solutions to this. They have done every single problem step by step. Don't wait for me to do every single problem. You start pulling apart and looking at some of these problems. And if you didn't understand what we did here, there's a detailed solution. There's also a playlist from YSU where you can find the exact problem and watch a video again for just that problem. So there's lots of stuff you should do between now and Friday. Okay?